Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the Business Logic Vulnerabilities module titled Excessive Trust in Client-Side Controls. Alright, before we continue with the video, I'd like to announce that this video is part of a course that I offer on my academy. Now you might be wondering, why would I buy a course that is made available for free on YouTube? Well, there are 4 reasons why you might want to do that. Number 1 is that you gain early access to recorded material. As soon as I record new videos, I make them available through my course right away, whereas on YouTube, they'll only be released on a weekly schedule. Reason number 2 is that you gain access to a Discord channel where you can ask questions. The Discord channel is divided into topics that we cover in the course, and if you run into any issues, you get to ask questions about anything related to the course material. Reason number 3 is that you no longer have to deal with YouTube ads or sponsor messages. And last but not least, reason number 4 is you get to support me. Any revenue generated from this course will go back into maintaining the academy and creating more videos and courses that will be made available for free on my YouTube channel. So if you're interested in buying the course, make sure to check out the link in the description. And that is it. Let's go back to our video. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy and then select all labs. And then do a search for Business Logic Vulnerabilities and select lab number 1 titled Excessive Trust in Client-Side Controls. Alright, let's get started. This lab doesn't adequately validate user input. You can exploit a logic flaw in its purchasing workflow to buy items for an unintended price. To solve the lab, buy a lightweight leather jacket. You can log into your own account using the following credentials, and they gave us user credentials. Alright, so the goal over here is to log in as this user and then attempt to buy this specific item over here. So it's called lightweight leather jacket, and the idea is to buy it for a price that is less than the price listed on the website. So for an unintended price, and the way we're going to do that is by exploiting a logic flaw. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already going through my Burp proxy. Alright, the first thing we're going to do is log into the account that we were given. And the password was Peter. Hit login. And then we're going to go to home and look for the item that we need to purchase. So notice over here, the credit that we have is $100, and the item that we want to purchase costs $1,337. And so we need to be able to exploit some kind of vulnerability in the application to reduce the price of this item to $100 or less so that we could afford it. All right, so let's click on View Details and analyze the requests that are being sent in Burp. So if we click Add to Cart, it's a post request to the application. So let's send that to Repeater. And then let's go to cart over here and attempt to buy the item. So again, over here, it costs $1,337, whereas we only have $100. So I'm going to click on Place Order and make note of the request over here. So again, it's a post request. So I'm going to send this to Repeater. And you could see over here, it says not enough store credit for this purchase. Okay, so let's look at the requests that we just sent to Repeater. The first one was when we add an item to the cart, and then the second one was when we actually try to buy the item. Now, if there is a flaw in the application, it would have to come from the client side, and so it would be parameters that are being sent to the server side that have that flaw in them. And so what I'm going to do is I'm going to check both requests to see if there are any parameters that I could potentially manipulate and be able to buy the item for less than what it is listed in the application. So if we look at the checkout one over here, you could see it only takes in a CSRF parameter, which comes from the /cart endpoint. So that's not something that will be useful to me because it doesn't change the price of the item. So my guess is that the vulnerability is in the /cart endpoint. So again, this is a post request, and over here, you could see it takes in a few parameters, and one of them is the price of the item. So over here, you've got 133700, and that represents $1,337. So let's hit send just one more time and see what happens. So it's a 302 redirect, and you could see over here now we've got 2 items in our cart. So let's remove them. And now my cart is empty. So what I'm going to first try is reduce the price to $0. So the idea over here is if this specific parameter is only validated on the client side and not on the server side, then I should be able to theoretically change it to any number that I want. And this is a vulnerability that I see quite often in applications. And so I'm going to hit send. And it is a 302 redirect, so that's already a good indication that it might have worked. Hit enter. And it still says my cart is empty, so that did not work. Another thing that you could try is maybe there is some kind of validation in the backend that doesn't accept a price of 0. So maybe the price has to be bigger than 0. So what I'm going to do is I'm going to change it to 1 and hit send. It's still a 302. Again, not sure if it worked. Let's reload our cart. And here we go. It did work. So now it costs 1 cent, which we can afford because we have store credit. So that's essentially the vulnerability in the application. The fact that there is no server-side validation on client-supplied input. And in this case, it's the price parameter in the application. So let's click on place order. And it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Before we do that, there was a few requests that we made that we'll require in this script. So the first one is logging in as the user. So if we go down right over here, this was the first request that we made. We're going to highlight that in green because we're going to need to perform all these requests in our Python script. So that's the first one. We logged in as the user. And then the second one is adding an item to the cart, which was this request right over here. And this one is in repeater, so we don't really need to highlight it. The third request that we made was checking out an item. So this one right over here, which again is also in repeater. So let's highlight it over here and make it green. In our script, we're going to need to perform all 3 requests in order to be able to automate the process of exploiting this vulnerability. All right, let's do that. As usual, we need to import the libraries that we need. So the requests library, the sys library, the URL lib3 library, and then from BS4, import beautiful soup. And then we're going to also import the regex library because we'll likely need it. All right, next we're going to disable insecure request warnings. So disable warnings, URL lib3.exceptions.insecure request warning. And then we're going to set our proxy setting. So proxies is equal to any HTTP traffic needs to be sent to my Burp proxy, which is running on HTTP 127.0.0.1, port 8080, and then we've got HTTPS traffic as well. Needs to be sent to Burp, which is running on 127.0.0.1, port 8080. This creates the configuration to make sure that all the requests in my script pass through Burp, just in case I need to debug them if the script is not working properly. All right, next we're going to create our main method. So we're going to say if name is equal to main, . Then we're going to call the main method, and we'll define the main method right over here. So we're going to say if the length of the command line arguments is not equal to 2, then print the usage instructions and the example instructions. So that means the user ran it incorrectly, and so we're going to try to help the user by telling him or her how to run the program. So usage, name of the program, and a URL, and we take the name of the program from the command line argument. Same goes for example instructions. So example, name of the program, and let's say an example URL is www.example.com. And again, we take the name of the program from the command line argument. And then we're going to exit the program because clearly the user ran it incorrectly. All right, this looks good. Now let's assume the user did run it correctly. The first thing that we're going to do is initiate our sessions object. So request.session. And then we're going to create a variable called URL. And that will be taken from the command line argument. So sys.argv1. And then we're going to call a function called byItem that takes in the session object and the URL. And this is a custom function that we're going to create right now. All right, so let's say def byItem, and it takes in the session object and the URL. Now, again, the order of requests that we need to perform is 1, we need to log in as the user that we were given. The second one is we need to add an item to the cart. And then we need to purchase the item and confirm that we solved the lab. So there's quite a bit of requests that we need to perform for this script, and it's likely going to be a long one. So the first thing that we need to do is log in as the account that we were given. So if we go back to the login request that we highlighted right over here, you could see it's a post request. And if we look at the parameters in the request, we've got the username, the password, but we also have a CSRF token. Now, the CSRF token is taken from the previous request, which is the GET request to the login page. So if we search for CSRF in the response of the GET request, you could see that the token was taken from over here. And so we need to be able to extract that token from the original request and then use it in order to perform our post request. And so that's going to be the first thing that we're going to do, which is retrieve the CSRF token. So to do that, let's set the login URL. So that's equal to URL plus the path to login, which is just /login. And then we're going to say CSRF token is equal to get CSRF token, and that takes in the session object and the login URL. So what's likely happening is that the application is using CSRF for every post request. And since we need to perform at least 3 post requests, we'll need to extract the CSRF token for each request. And so instead of implementing the same code every time, what I'm going to do is I'm just going to create a function called getCSRFToken and then call it every time I need to extract the CSRF token. So we'll do that right over here. But before we do that, actually, let's say rest of code here, just so that we know that this is not complete. All right, so to extract the CSRF token, we're going to say def get CSRF token. It takes in the session object and the URL. And we're going to say r is equal to s.get. So a get request to the previous page, it takes in the URL. And in this case, the URL is the path to the login page. We're going to set verify to be equal to false and proxies to be equal to proxy so that the request gets sent to Burp in case I need to debug it. And then we're going to use the beautiful soup library to parse the response. So r.text we're going to say html.parser, and then we're going to say csrf is equal to soup.find. And essentially over here, we need to find the CSRF token. So the CSRF token is an input element that has a name attribute that is equal to CSRF, and the CSRF token is in the value attribute. And so to find it, we're going to say look for the input element, where the name of that input element is equal to CSRF, and I specifically want the characters that are in the value attribute. So this right over here. And so right now it extracts it, and I'm going to return CSRF. And now we could use this function every time we need to extract the CSRF token. So when we call this function on the login URL, it'll extract the CSRF token and it'll save it right over here. Now I have pretty much everything that I need in order to log in as the user that we were given. So I'm going to say login as the user, and we'll print a statement saying that we're logging in. So logging in as the user. And to do that, if we go back to our post login request, we have a few parameters that are in the request. And so we're going to say data login is equal to the list of these parameters. So CSRF, and that's equal to CSRF token, the value that we just extracted. And then we're going to say username is equal to the username that we were given, and password is equal to the password that we were given. All right, this looks good. Next, it's just a matter of performing the request. So we're going to say r is equal to s.post because it is a post request. It takes in the login URL. And then we're going to say data is equal to data login. Verify is equal to false because I don't want to verify TLS certificates. And proxies is equal to proxies because I want my request to be sent to Burp. And then to confirm that I've logged in, I'm going to say the response is equal to r.text. So I'm saving it in a variable called res. And then I'm going to check if log out is in res. If it is, then I'll print successfully logged in as the user that we were given. Otherwise, I'll print could not log in as user. All right, so the idea over here is when you're logged into the application, you should be able to see a log out button so that you could log out of the application. And I think this timed out, so we won't be able to see it over here. But if we go right over here, so after we've logged in and we look for log out, here we go. You see that you have the ability to log out. So if you see that, that means you've successfully logged in as a user. If you don't see that, that means you haven't logged in as a user. All right, so this completes this item right over here. Now the next step is to add the item to the cart. So let's bring that up and add a comment saying add item to cart. Now, if we go to repeater over here, the request is this one right over here. So it's a post request. It's to the /cart endpoint, and it takes in these parameters right over here. And so we're going to say cart URL is equal to the URL of the application plus /cart. And then we're going to say data cart is equal to the parameters of the request, which is product ID. And that's equal to 1. And then we also have read dir, and that's equal to product, and then quantity, and that's equal to 1, and price, and again, that's equal to 1. All right, so that's all the parameters that are in this request right over here. Next, we perform the request, so R is equal to s.post. It takes in the cart URL that we just set, and then the data that we also just defined, so data cart, set verified to be equal to false, because I don't want to verify TLS certificates, and proxies to be equal to proxies, because I want the request to be sent to Burp. All right, so this performs this request right over here. So if we go back to our notes, we're done this item as well. Now it's a matter of purchasing the item. So let's add a comment saying checkout or purchase the item. And for that one, it's this request right over here. So it's a post request and it's to the endpoint /cart/checkout. And this one takes in a CSRF token. So we're going to need to extract that CSRF token again. So we're going to say checkout URL is equal to URL plus the endpoint, which was /cart/checkout. And then we're going to say check out CSRF token. And we need to extract this token from the previous request, which was the /cart request. So we're going to say get CSRF token. We're calling this function right over here. And we're passing the session object. And the URL is going to be the cart URL. Okay. So now this is the only parameter that we need, so we should be able to perform our request. So we're going to say R is equal to s.post, and we'll say checkout URL, and we actually need to save that CSRF token in a data parameter. So we're going to say data checkout, and that would be CSRF, and that's equal to the checkout CSRF token that we just extracted. All right, so data over here is equal to data checkout, and then verify is equal to false, and proxies is equal to proxies, and that is it. All right, so we performed this request over here. Now it's a matter of confirming that we solved the lab. And the way we're going to do that is we're going to look for the congratulations you solved the lab message. So let's add a comment over here saying check if we solved the lab. And again, the way to do that is we're going to look for the congratulations string in the response of this request over here. And if we find it, we'll print successfully exploited the business logic vulnerability. But if we don't find it, we'll say could not exploit the business logic vulnerability. And we'll exit the program because the exploit failed. All right, hopefully there's no errors in my script. So let's save it. And let's create a new instance of the lab. And while that's loading, let's review the script. All right, so the first thing that we did is create the main method. In there, we initiate the sessions object and we call the function by item that takes in the session object and the URL of the application. In that function, the first thing we do is retrieve the CSRF token in order to log in as the user that we were given. After we successfully log in as that user, we add an item to the cart where we set the cost of the item to that pressed on the wrong place, where we set the cost of the item to $1. So I'm going to click on view and word wrap so that we could see everything in front of us. After we successfully add an item to the cart, we purchase the item by checking out the item, and then we check if we solved the lab by looking for the congratulations string in the application. Hopefully there's no errors in my script, so let's run it. Terminal, new terminal, and we're going to say Python 3 business logic flaw 01 and the URL of the application. So let's copy that, paste it in here, and remove the trailing slash and hit enter. So far so good. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of a business logic vulnerability. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you and see you in the next video.